Let's talk chemistry with Pastor Dan. We're looking at mass volume stoichiometry. Now, this only differs from the last stoichiometry we did in that instead of doing with masses directly, we also remember we have molar volumes. Remember, volumes is 1.1 mole is equal to 22.4 liters of any gas at STP. STP stands for standard temperature and pressure. We're going to look at a section on ox-redox reactions, and then we're going to come to gas laws, and we'll talk about that there. So that being said, here's a problem. Determine the volume of carbon dioxide gas formed when 33.22 grams of butane, C4H10, is burned in the presence of excess oxygen. Now, I don't have reacts with, but I have the word burns. Now, because that shows that it's combustion. Remember, the products here are CO2, H2O. So balance it up, I'm going to put a 2 in front of the C because I end up with a 4 and a 5 gets odds and evens. So we're going to double it up. So 8 and 10, and that gives us 16 plus 10, 26, 2, 13. So there's our balanced equation. Put our given over 1. So 33.22 grams C4H10. That is a compound, so we need a formula mass. So carbon, hydrogen. 12 is the atomic mass of carbon times 4 is 48. 1 atomic mass of hydrogen times 10 is 10. So 48 and 10 is 58 grams is 1 mole. So 1 mole C4H10 is 58 grams. So the grams cross out. We're in C4H10. I'm asking for CO2. Find the volume of carbon dioxide. So the equality there is 2 moles of C4H10 is 8 moles of CO2. We want to get rid of C4H10, so it's going to go on the bottom. CO2 is going to go on top. So we got 8 moles over 2 moles. And then I want volume. So remember, we're talking about volume of a gas. And it doesn't say it. We're going to assume right now that's STP. So that tells us that 1 mole of CO2 is 22.4 liters CO2, molar volume of gases. So 22.4 liters CO2 over 1 mole. Take them all by 3, 33.22 times 8 times 22.4 equal divide by 58, divide by 2. How many sig figs? I get 4. Answer is 51.32 liters of CO2. That's my answer. Let's try going the other way. This time, what is the mass of carbon needed to form 98.22 liters of carbon dioxide gas in the synthesis of carbon dioxide? Now, synthesis, again, it doesn't say reacts with, but says synthesis. So therefore, we identify that's from our elements, carbon plus oxygen, CO2. Look at it. It's already balanced, as is where is. So take our given and put it over 1. Now, we'll start with volume. So therefore, we're going to use our molar volume here. That 1 mole, it should be 1 mole, not 1 liter. Let me fix that. Sorry about that. There we go, 1 mole. So we'll fix that at the end there. All right, so 1 mole of CO2 is 22.4 liters. From our balanced equation, we're doing carbon and carbon dioxide. So therefore, the mole relationship is 1 to 1. So 1 mole of C is equal to 1 mole of CO2. Look at the periodic chart right here. Look at carbon. Carbon's atomic mass is 12 grams. So we answer, cross everything out. We get 52.62. And make sure I change this over here to moles because that bothers me. There we go. All right, awesome. Now we have one more we can do. And this can be real quick. The answer is 67.858. Now, before you get too impressed, let me explain what we got going on here. Okay? Here's our reaction. It's the synthesis of water. Now, balance it up. Take our given over 1. Now, remember, this is 22.4. And the end is going to be 22.4. So they're going to cross each other out. So I can get rid of those and only deal with the molar relationship. So 1 mole of H2O over 1 mole of oxygen from the balanced equation. Oxygens cross out, moles cross out, and it was 67.858 liters. Now that only happens when we're going from volume to volume at STP. So because, remember, we're going to do the 22.4 liters is 1 mole to start, and then the 1 mole is 22.4 liters at the end. So the two 22.4s, we'll cross it out. Real quick, got it good to go. All right, so here we go. let's look at this one right now. We have these two problems. Stop the video here. Try to get these, work them through. We're going to show it to you in a second. Pause it. All right, here we go. So for the first one, there's our balance equation. We have our given over 1 molar volume, balance equation, there 1 mole to 1 mole. And from the atomic mass, we get 100 grams. So the answer is 133.91 grams, CaCO3. For the second one, there's our balance equation. And because we're going volume to volume, again, it's one step because my 22s will cross out. So the answer is 27.33 liters. All right, hopefully that wasn't too bad. Take care. Be good.